Good afternoon, everybody. This is a live extreme weather briefing as we have a lot to discuss with the enhanced risk over central Minnesota and a morning complex of storms that has acted to stabilize the atmosphere across northern Minnesota just ahead of that surface low. The surface low is not as deep as the NAM model was forecasting yesterday. Yesterday, the NAM model was forecasting surface low in the upper 990s by this time, but it's definitely not as deep. It's about 1,004 millibars right now. So I'm going to show that in just a second. But I wanted to begin by discussing the derecho that impacted and devastated many parts of central and eastern Iowa through northern Illinois on Monday, August 10. Extreme crop damage out there as well. Many farmers lost everything. Still substantial structural damage. Hundreds of thousands, I'm hearing, are still without power across many of these communities. Linemen are coming from many states away to try to help out communities like Cedar Rapids, but people are still without power there. I've had many Iowans reach out asking for help to put eyes on this situation, to put attention on this recovery effort. So Ginger and Mandy from the Team Dominator support community have put together this webpage on teamdominator.net. And this is dedicated to the Midwest derecho. There's a bunch of links as well to charity organizations, reputable local charities that you can check out to help out in the recovery effort. You can see the new logo here as well for the Team Dominator Storm Recovery Foundation that we've just begun. But basically, we're just going to organize information if you do want to help out in storm recovery, not only tornadoes and hurricanes, but events like derechos, wildfires, really anything weather related we're going to focus on. But this is a website that we have dedicated for the derecho that really devastated large portions of the Corn Belt. Farmers, residents there work really hard to put food on the table worldwide, and we definitely want to help out in any way that we can. And this is on teamdominator.net. Just put together and rolled out here recently. And now I want to talk about another severe weather event a little bit further north in the Corn Belt. This is on the Radar Omega app here. And this is a complex of storms that has really been persistent so far this morning. This is the southern edge where there's still a bit of convection, some new elevated convection even going up behind it. And there's a lot of lift right now in the atmosphere with that upper level trough ejecting. Some cyclonically curved mid and upper level flow beginning to impinge on this warm sector. There's a surface low oriented across eastern North Dakota at about 1,004 millibars. A ton of warm advection out ahead of that, a strengthening low-level jet. And right along that boundary that separates the stabilized air across northern Minnesota to the east of North Dakota and the unstable air off to the south, those increasing southerlies out ahead of the surface low. Those are getting forced up and over the cold air or the relatively stable air at the low levels. It's a shallow layer, and this is classic isentropic lift here. You're getting convection, elevated convection, little blobs of storms that are getting elevated over that shallow, stable air. But this complex of storms that developed overnight, continued this morning, definitely had some severe weather, some severe thunderstorm warnings across northwestern Minnesota. This has acted to stabilize the atmosphere across northern Minnesota, and that's where the most favorable kinematics or wind shear was going to reside for severe weather and a tornado threat later on this afternoon and evening. And so this complex of storms has acted to pinch the warm sector just a little bit. For that reason, the Storm Prediction Center has moved the enhanced risk a little bit further south. It's across central, southern Minnesota now, and that's anticipating the development of further storms along the southern flank of this MCS, a little bit closer to that warmer air, and there still is a possibility of an isolated tornado or two. The significant hail zone, the hatched area for significant hail, has been removed from this area, and that's because destabilization in the warm sector has been inhibited by this morning convection across northwestern Minnesota. And we could break down the surface map, but first I want to show you that enhanced risk that has been shrunk down a little bit by the Storm Prediction Center, given the updates this morning with that complex of storms. And there you can see that enhanced risk in place across central Minnesota, from due east of Fargo down into south central Minnesota. This is the hot spot so far this year, where the Dalton tornado happened in the northern side of this risk. Minnesota has definitely had a pretty active severe weather season when many parts of the rest of the country have been very inactive. In fact, the southern plains were historically inactive so far this year, with I think only just that one lone tornado watch that ended up busting in northwestern Kansas back in May. But now we've got a slight risk that extends all the way down the front into the southern plains, into western Kansas, where severe weather is possible as that front unzips this evening, with severe weather developing along it. But the greatest wind shear is going to be up north across northern Minnesota into southern Canada, southeastern Manitoba, southwestern Ontario. But the instability is going to be lacking up there because of that morning complex of storms that has acted to stabilize the atmosphere across northern Minnesota. But there could be severe weather all the way down into the Texas Panhandle along this front. This is a very large system. It's possible that today is going to be the last day of a tornado threat up in the Canadian prairies, as we're really starting to get late in the seasonal cycle as we're approaching mid-August. But similar to how last year in northeastern Colorado, eastern Wyoming, and the western Dakotas just went completely nuts during July and August, the same thing has happened up in the Canadian prairies, southeastern Saskatchewan, and the southern Manitoba. Some pretty substantial tornadoes, including one yesterday near the Brandon, Manitoba area that Braden Morrisseau intercepted with the Prairie Chasers. Beautiful white tornado illuminated by the sun back behind. Almost reminded me of the Mulvane, Kansas tornado from June 12, 2004 up there. Definitely an interesting setup as well, kind of back behind the main instability that was focused over northwestern Minnesota up there. Quite a bit of wind shear though, ahead of that big upper level system. That tornado was a supercell that was anchored underneath the core of that strong cyclonically curved mid-level flow. A lot of cold air aloft up there as well. But today, that same storm system is going to bring the threat of severe weather across central Minnesota, and a little bit less significant than we thought that severe weather was going to be yesterday during this time, especially with the NAM model showing that 997 millibar surface low moving across northern Minnesota with a attendant low-level jet that looked like it was going to completely go nuts. We're still going to have that strong low-level jet, still some pretty strong parameters for wind shear, but even to the south of the MCS, you've got this belt of modified dew points into the low to mid-60s. You got some 62s down there, and really those deep corn belt type dew points that you get are confined to southern Minnesota. It is lifting off to the north as that low-level jet is beginning to develop to the east of this system, and I do expect this pseudo-warm front, basically a differential moisture gradient, to continue to lift north, and once it gets up close to the southern flank of that MCS, that's when I expect severe storms to erupt at around 3, 4, 5 p.m. Central Time, and those will march off to the east in a north to south line, eventually getting close to the Minneapolis-St. Paul area by evening, about 7 or 8 p.m. out there. But there are still some discrepancies in the short-range models on how the convective scenarios are going to evolve. I think that the RAP model seems to have the best handle on the positioning of the morning MCS, this differential moisture gradient being into southern Minnesota. So I think that the RAP model seems to have the best handle on convective evolution this late afternoon through evening. The HRRR does some weird things with a surface low, dropping the surface low down with the MCS and then lifting it back to the north. And because of that weird behavior dealing with the surface pressure pattern in the HRRR, I think that's driven largely by convection, and that MCS is probably releasing a lot of latent heat. I've decided to go with the RAP model. It's one of my favorite models as well for the short range and for predicting how the atmosphere is going to respond to morning MCSs. Will it recover? Will the MCS intensify? How is the convection going to evolve through the afternoon? And we're going to go with the RAP model, but we're going to look at all of them. So here is the initialization of that MCS by the most recent RAP model. It has that MCS located due to the east of Fargo. It's got the surface low just to the northwest of that, 1,004 surface low, not as deep as the NAM was forecasting yesterday with that 997 surface low lifting through northern Minnesota into southwestern Ontario. This one's a little bit weaker, and all the models have gravitated toward that less deep of a surface low scenario, and with this MCS continuing through the early afternoon hours. But the HRRR has that MCS a little bit too far north, at least the recent HRRR runs, and so that's probably why we're going to throw out that model, but we're still going to look at it anyway. But this is the RAP initialization. Actually, this is the forecast Nope, that is the initialization. And then here is the prediction as we're getting closer to 7 p.m. Just a very slow propagation of that surface low across northern Minnesota. The evolution of a convective line developing, extending all the way into southern Minnesota. That's where the enhanced risk is located, basically covering this zone of convection to the south of the surface low. The east side of the surface low in the northeastern quadrant, that's where the best wind shear is located, the best kinematics, strongest low-level jet, most back surface winds. But this is dominated by stable air, as we've seen on the surface map and as we've seen in the short fuse models. And really, the arrival of that strong instability is going to be down here, where you have less favorable low-level shear, but still the RAP model is showing the chance of isolated tornadoes with 300 to 400 0 to 1 kilometer storm relative felicity. The HRRR has a little bit less wind shear out ahead of this north-south convective line. Another negative, though, that could hinder tornado potential is that the storm motion is relatively meridional, north-northeast, maybe northeast for a dominant right mover, and with this front being also oriented to the south-southwest of the northeast, that's going to encourage a lot of cell mergers, and there's also a surging cold front on the south side of the surface low that could act to undercut the convection, leading to a bit of a more of a linear configuration to that convection to the south of the surface low, a little bit forced as well, and that usually leads to linear modes. But with the magnitude of low-level wind shear, and we'll show you some of those photographs, what it looks like, I think there's a decent chance of tornadoes this afternoon. This is the storm relative felicity as predicted by the RAP model. It's really effective storm relative felicity, but gives you an idea of where the strongest wind shear is located. It also factors in if storms will be potentially surface-based or be able to access that low-level shear. And here you can see the strongest low-level shear across northwestern Minnesota. But with that MCS ongoing, there's some questions as to whether this is going to be surface-based instability this far north, co-located with that very strong low-level shear. But you can see this lobe of 200 to 300 0 to 1 kilometer wind shear extending to the south of the surface low. Even though the surface low is in the low thousands instead of the high 990s, there's still plenty of wind shear as that low-level jet accelerates over top of that. And you can see the severe weather beginning to unzip down the front through eastern Nebraska, eventually down into western Kansas where that slight risk is located. But at 4 p.m., there's plenty of wind shear for any of these blobs if they're surface-based to develop a tornado threat. That's why I think there is going to be tornado warnings this late afternoon and evening across central Minnesota as that new convection develops on the southern flank of that MCS. And then as we step forward to 7 p.m., I'll show you how the RAP ejects the wind shear. Not very rapidly, just continues it off to the east along with that convective line, eventually moving toward the Minneapolis-St. Paul area by about 7 or 8 p.m. And as that surface low moves east, the axis of the low-level jet also does, and there's pretty strong low-level shear all the way down to near the Minneapolis area. So when that convection moves in, likely just after sunset to Minneapolis, there is a chance there could be a couple tornado warnings on the southern flank of that convective line. And as we mentioned, the best kinematics are going to be in northern Minnesota up into southwestern Ontario. But I just don't think there's going to be a huge amount of instability up there because of the morning MCS kind of shunting that transport of those 70s dew points northward into the more favorable kinematics to the northeast of that surface low. But if there was instability up here into southwestern Ontario, far northern Minnesota, we'd probably be talking about an outbreak of tornadoes up here. But thankfully, this complex of storms has prevented the transport northward of those 70s dew points. I still think there's going to be some tornado producers, though, on the southern flank of that MCS with the new development. So now let's look at the HRRR. This is the 16Z HRRR analysis, and I wanted to show you that it was a little bit inaccurate with its position of the MCS at this time. The MCS is actually a little bit further south, due east of the Fargo area, as I just showed you on the Radar Omega app. And so you really, the HRRR is already starting with inaccuracies. That's never a good way to start with the model initialization. It does have the surface low accurate, but it does seem to have the surface low a little bit too far south. You can see that there are a hint at some closed isobars there in northeastern South Dakota. But really the main surface low is up in eastern North Dakota, according to the surface map, according to the RAP analysis. So when you step forward to 4 o'clock p.m., look what the HRRR does with that surface low. It actually wobbles it a little bit south, consolidates it across central Minnesota. It's possibly driven by convection in this MCS, leading to a diabatic heating minimum leading to latent heat release and certain low-level pressure falls. But really what's going to happen is this surface low should just cruise in a nice smooth path across northern Minnesota from eastern North Dakota, northern Minnesota, into southwestern Ontario as we go through the evening. I don't think there's going to be this wobble of the surface low and then back north. And as we go to 7 p.m. on the HRRR, it brings the surface low back up to southwestern Ontario where it should be. Unzips the line down through the Minneapolis area. The HRRR is a little bit faster of a solution than the RAP model, bringing that convective line into Minneapolis by 8 or 9 o'clock. Some of these could be tornado producers on the southern flank. As we saw, there is that little lobe of enhanced low-level wind shear that extends south of that surface low, along that trough axis to the south. And I think there's going to be a maximum in severe weather further south in western Kansas, but I think there's going to be a little bit of a break in severe weather through western Iowa into eastern Nebraska. It'll probably take on more of a bimodal type of configuration with the severe weather. But let's go back to that MCS, and I can show you the early inaccuracies with the HRRR and how it's initialized this MCS just a little bit off. And it's also underestimated the elevated convection that's going to be developing behind the MCS in the vicinity of that surface low. But here's the radar Omega app. There's even some flash flood warnings in effect just to the southeast of Fargo, to the north of Fergus Falls, Minneapolis. Here is that flash flood warning in effect right there. A lot of convection this morning, quite a bit of rainfall. Looks like that's going to continue for another hour and a half in northwestern Otter Tail, east central Wilkin County until 3 p.m. Since 9 o'clock, or at 9 o'clock this morning Central Time, Doppler radar indicated between 5 and 7 inches of rain. So that's big time rainfall. There's still some stratiform rain falling about throughout the flash flood warning area. Some special weather statements indicated for this convection that appears to be streaming over the same area. And really it looks to me, since I started putting together the material for this briefing, that this MCS is a lot more complex and a lot more expansive than even the RAP model was showing, as you've got all this new convection starting to form to the northwest of it. The RAP and the HRRR kind of have a confined area of convection on the southern end. So with this being more substantial, it's definitely going to prevent northern Minnesota from destabilizing likely anywhere to the north of that line, and that's where a lot of the favorable kinematics are located. But the RAP model and even the HRRR, despite its inaccuracy, still has that lobe of decent wind shear extending to the south of that MCS, and there should be renewed development here to the west of St. Cloud, central Minnesota, and the central and southern part of the enhanced risk area, and there could be just enough of a tail end of wind shear there to develop a tornado threat. So that's what we're going to be watching later on this afternoon. So thank you everybody for joining me. I usually do these updates like this through the Facebook supporter community, but I wanted to put some eyes on the recovery effort from the derecho that impacted large portions of the Corn Belt on Monday, August 10th. We've put together a web page on the teamdominator.net website with a list of charities, local charities that are reputable at the bottom. If anybody wants to help out in that recovery effort, we've got the Iowa Community Action on there, Habitat for Humanity, Baptist Convention of Iowa, the Red Cross, of course, even Animal Rescue League of Iowa, to be mindful of those pets out there that may have been displaced or might be suffering in the heat because of the lack of power. But there's the local charities. And really quickly, before I let you go, I want to take a look at the 3-kilometer NAM because it handled yesterday so perfectly with the expansive line of storms that would dominate Minnesota. And look at how fast the HRRR is. It's the fastest model of any of them, bringing the convective line well through the Minneapolis area by 7 p.m. And by 4 p.m., let's first see what it did with the MCS. Might be able to just throw this model out. So even the 3-kilometer dam was inaccurate with the position of the MCS being too far north. It's really down here to the southeast of Fargo. But it is doing a good job with the redevelopment of elevated convection on the backside and kind of having a more geographically expansive MCS. And the HRRR converts from that MCS to an unzipped line of storms. No supercells, and you really want to take this with a grain of salt because this is not a convective allowing model. But it's done a really good job the last few days, at least on the U.S. side, with how expansive this convection would be. And it has that squall line blowing through Minneapolis, even right around dinner time, with possibly hinting at some circulations within that line, maybe some QLCS tornadoes as the wind shear is quite strong. That low-level jet out ahead of it is pretty substantial. But it's not as deep of a system as it was before, kind of an elongated banana-shaped low now, instead of consolidating into the upper 990s as the NAM was showing yesterday, and more of a unidirectional shear profile over most of the warm sector, instead of some backed winds up in the Missouri Arrowhead and southwestern Ontario, but largely the atmosphere has been stabilized by that more expansive MCS. So that's what we're looking at today. Stay tuned to those watches and warnings. Stay tuned to the Radar Omega app, and I'll go live later on this afternoon if a more substantial tornado threat develops across central and northern Minnesota. So thank you, everybody. I hope you enjoy my weather reports. Never stop chasing.